Hey everybody, Mr. Sharkey back with another exciting chemistry video. Today we're looking at Unit 1, Worksheet 3. In particular, we're looking at question number 4. And question number 4 takes up a whole page, so hopefully that gives you an idea. This is a pretty intense question, but hopefully we can kind of break it down and make it a little bit easier for ourselves. So in this first question, we have a couple pieces of information. Number one, we've got this graph that's over to the side. This is a mass versus volume graph. So hopefully after looking at our 3 levels and discussing the lab, we'll realize that the slope of this line, or each of these lines, I guess I should say, is going to equal the density of our objects. And again, the reason we know that is because slope is rise over run. And in this case, the rise is our mass and the run is our volume. So mass divided by volume is our definition for density. And with the way that we've set up our axes, that is also our slope. The other part of question 4 that I think is tricky is this idea of a two-pan balance. Hopefully, just looking at this picture, you guys will realize what a two-pan balance is, or at least what it's similar to. If you ever spent time on the playground as a youth, perhaps you remember a teeter-totter or a seesaw. Two-pan balance is essentially one of those. It is just comparing two objects to each other. And we've got questions A and B that we're going to go over together before we really get into the sauce here. Question A says you've built a simple two-pan balance, shown above, to compare the masses of substance A and B. What would happen to the balance if you put equal masses of A and B in the two pans? So they are saying, what if we put 50 grams of A and 50 grams of B on our two-pan balance? So we could say that both of these masses equal 50. If both masses equal 50, that means that we have an equal amount of mass on both sides, and gravity is going to pull both of those masses down, and we'll actually see that the balance would level out. So in this case, if our masses are equal, we would expect the balance to be flat, or some people would say level, or some people would say balanced. If we look at our table here, at our graph, if I want 50 grams of A, it looks like I need a little bit more than 30 milliliters of A. But if I want 50 grams of B, I'm going to need quite a bit of B. If we extrapolate this line, if we continue going up, it looks like we'd need at least like 90 milliliters of substance B to make those two pans balance. So that kind of leads us towards question B down here, which says what would happen if equal volumes of A and B were put into the two pans? So now we're not talking about mass anymore, so I'm going to erase these. We're talking about volume. So let's say that we put 50 milliliters of A, and then we also put 50 milliliters of B, and it's asking us to predict what would occur. So we can actually use our data table again. So if we look, this whole line here is 50 milliliters, and we can follow it up to A. So if I had 50 milliliters of A, it looks like I'm right at 80 grams. So we can expect that that would have 80 grams of mass for substance A. On the other hand, if I had 50 milliliters of B, it looks like I'd have about 25-ish grams. And what that tells me is that all of a sudden my teeter-totter is no longer going to be balanced. It's going to fall down towards one side. And the question that I want you to think about is which side would get pulled down to the ground? Hopefully you realize that substance A would get pulled down towards the bottom because, like we said, our mass here would be 80 grams if we had 50 milliliters of each. Whereas the mass for substance B would only be 25 grams. So we could say something like, because A would have more mass, A gets pulled down. Something along those lines would work. I don't think that questions A and B are the hardest part, but I do think it's nice for us to kind of talk about these things together because it's probably been a while since you've been on a teeter-totter, and also you might not have seen or actually used a two-pan balance before. So then if we look at question C, it asks us to find the slope of the line for both line A and line B using correct units. And then we're going to state the physical meaning of the slope. We already said that slope equals density, so that is the physical meaning that it's talking about here. But I still want you guys to actually practice finding the slope for A and finding the slope for B. It's probably been a minute, so if you need an equation to use, remember y2 minus y1 would be how we find the rise, because we find our higher point and subtract our lower point. And then we could divide by x2 minus x1, which is the equation for how we'd find our run, because we take the point that's further to the left and then subtract the point that's further to the right. Flip that. Sorry, trying to. Too many. The camera doesn't reflect me. Whatever. Regardless, I'll show you A real quick. So if we look, when we're doing this calculation, because it's slope, that means we need 2 points. We already talked about the fact that it looks like 50, 80 matches up pretty well for substance A, so we can go ahead and use that as one of our points. And then if we look, the other point that sticks out to me is down here at 0, 0. So even though I'm using 0, 0 as a point, that's still a point, so I still need to track it. So I'm going to take my y2 minus y1, so in this case that'd be 80 minus 0. And then I'm going to divide by x2 minus x1, which in this case is 50 minus 0. And then if I include parentheses like this, I could just plug that straight into my calculator because I'd be keeping track of the order of operations. But a lot of us are not very good at our calculator skills yet. So what I would recommend you do is just simplify the fraction as much as possible. So here, 80 minus 0 is 80. 50 minus 0 is 50. If I have 80 over 50, I could reduce that fraction down to 8 over 5. And then that is what I would plug into your calculator so that you're not making a mistake. When we do that, it would become 1.6. Looking at this, it might look like I'm done, but we were asked to include the correct units. If we look, this was 80 grams minus 0 grams. So grams is my unit on top. And then for my run, that was 50 milliliters minus 0 milliliters. So no matter how I write my slope, the units will always be grams divided by milliliters in this question, because I'm always taking my y, measured in grams, dividing by my x, which is measured in milliliters. Again, I want you guys to take a second, actually try to do the slope for B on your own. So pause the video, see if you can calculate it, find your 2 points, come back, and then we'll catch you up. Cool. The 2 points that I identified are 40, 20, and then again 0, 0. So here we would take 20 minus 0 grams divided by 40 minus 0 milliliters, which would simplify down to 0.5 grams per milliliter. So there's the slope of both of our objects. Now we're going to get into the actual sauce. So this is where things start to get tricky, and that's starting with question D. I'm going to walk you through D, and then I'm going to leave E to you, even though E is a little bit harder. It says if we put 10 milliliters of A in one balance pan, what mass of B would you need in order for the other pan to be balanced? And then we have to explain our reasoning. So we have our 2-pan balance, and we know that we have a container of A that has a volume of 10.0 milliliters. We also know that our pan is balanced with a container of B on the other side. And we've been asked, what is the mass of B? At first, this seems a little tricky because we don't have much information about B, but we've been told that our two pans are balanced. And if our pans are balanced, that means that the mass of A has to equal the mass of B, because that's the only way that those two pans will be sitting flat. So we have the volume of A, we have the density of A, and we can use those two numbers to try to find the mass of A. And if we find the mass of A, that is going to tell us the mass of B. So this seems kind of complicated, but really the way that we could rephrase this question, we could just say to ourselves, what is the mass of A? That's the thing that we're going to try to solve for. So right now, we know the density of A. We said it was 1.6 grams per milliliter. And we're going to use our good friend of proportion, because a proportion, like I said at the beginning of class, is basically the only type of math we need to do in order to be successful in chemistry. So I can rewrite this as a ratio by putting 1.6 grams over 1 milliliter, because mathematically that's the same thing. But now I have it in the format that we're used to for our unit conversions when we're making proportions. So on the other side of my equation, I'm going to put grams on top and milliliters on bottom. An important thing for us to note here is that all of this is talking about substance A. So I'm talking about grams of substance A and milliliters of substance A. We do not know how many grams of A we have, but we do know that we have 10.0 milliliters of A. So all of a sudden, we took our density and rewrote it as a ratio, and then we set up a proportion using the stuff we had from the question, and now we've got a proportion that we can solve with cross multiplication. And what you should see here is that x is going to equal 16.0 grams of A. Nice. But that doesn't mean we finished this question. We still need to figure out the mass of B. However, because our two pans are balanced, if I have 16 grams of A on one side, that means I need the exact same mass of B on the other. So if I have 16 grams of A, that means I also have 16.0 grams of B, and bada bing, there is our final answer. Question E is a little bit trickier because we start with the volume of B, and we are asked to end up solving for the volume of A. So I'm going to lay out a plan for you, and then I'm going to let you try to solve it on your own. If we have the volume of B, we can find the mass of B. We'd have to use the density of B in order to do that. And then because, again, we're told that our two pans are balanced, if we find the mass of B is always going to equal the mass of A for these two pan balance questions. So then, once we have the mass of A, we can use the density of A to find the volume of A. So there's two steps here. Step one is going to involve everything we know about B, so the volume of B, the mass of B, and the density of B. And then step two is going to involve the mass of A, density of A, and volume of A. I want you guys to give this one a try, even though it seems pretty intimidating. But I think this is the hardest question on here. So if you can get your mind around E, the rest of these questions should be a breeze. If not, I would encourage you to try the rest of worksheet 3 first, and then come back and do question E at the end. but I expect we're going to have a little bit of time to talk about it on Wednesday. Your homework is going to be finishing the rest of worksheet 3. I want you to at least try all of it, even though I've been absent today. So go ahead, spend the rest of class until the assessment working on that. And if you get stuck on something, that means you have a question. So I'd encourage you to try to write out your question so that you can actually ask it next class. Thanks, everybody, and I will see you all soon.